Let's talk about half-life in this part. Very common idea in maths and science. So half-life is, for example, of half-life of a certain substance is 10 years. What does this mean? This means, for example, if I have 1000 grams of some substance, so after 10 years, because half-life is 10 years, it will remain half of 1000, which is 500 grams. Again, after 10 years, it will be half of 500, which is 250 grams. Again, after 10 years, according to half-life, 250 gram will be left 125 grams. This is what half-life is. So let's take a common example of carbon 14, which is a half-life of 5730 years. Too much. Suppose initial amount is 1000 grams, right? So after 5730 years, that amount will be 500 grams. Again, after 5730 years, that will be 250 grams. That means in total, this plus this, 11,460 years, it will be 250 grams if the initial amount was 1000 grams, right? So we can say like it's just a special case of exponential decay because the substance is decaying, right? Um, but it's a special kind of decay when time is fixed, right? When it will become half of the previous one. So it's just a special case of exponential decay. We will use that equation, therefore. So the general equation is A is equal to A naught e raised to power negative kt, where A is the initial amount, A naught is the A is the final amount, A naught is the initial amount, K is the decay constant. K is the decay constant. That means at which rate it's decaying, and T is time. Now let's see one point here. K has to be positive. And this negative sign here with the formula shows decay. That means something is decaying. And because, final amount is always half of the initial amount, so I can replace final amount by half of initial amount, right? And dividing by initial amount on both sides, we will be left with 1 by 2 is equal to e raised to power negative kt. Now we have to find k, and here it is in the form of power. So what we do, we apply natural log on both sides. That is equal to natural log of e raised to power negative kt. Now let's stop here and learn one or two concepts. So let's revise them. If you have log of m raised to power n, that power is on m only, then according to property it is log of m, right? And second property is like if you have some base here, log of m to the power m, this is base rule, base m, number m, this becomes log of m over log of m, which is equal to 1, right? So if base and number are same, this becomes equal to 1. So if I convert this base and this into e, it will be 1. And if base is e, this is known as natural log. So we can write it like this. So natural log is equal to 1. So I'll apply this property as well as this property. So natural log of 1 by 2 is equal to negative kt. Perfect. Again, because we are talking about half-life, right? So this k will be, this time here will be half of the time. Means half-life time of that particular substance. Half-life time, half-life time, half-life time, half-life time. Now we need to find k. So that means we have to divide by negative t half-life is equal to k. Okay. Now, because this is a negative sign in the denominator, we can write it in the numerator. Okay. Again, I am using this property opposite. If n is the negative sign here, so I am just giving it as a power. That is natural log of 1 by 2 raised to power negative 1 over half-life period is equal to k. Now, if we see the very basic property of exponents, the negative exponent rule. So, if 1 by 2 has a power of negative 1, so if we reciprocate, the power sign of the power changes. So, that means it is natural log of 2 over half-life period of certain substance is equal to k. It's a formula. It's the value of the decay constant, value of k, right? For example, if you have a question where you have to find the decay constant, you can apply this formula directly. Now we will derive the direct formula of half-life. And let's see, find a connection between k and the half-life definition. So by definition, t is actually the half-life of that. Okay. Now the basic formula or the general formula exponential decay is A final amount is equal to initial amount e raised to power negative kt. So I will replace this k here. No, okay, forget about this. So A is equal to A naught e to the power. Now what is the value of this? Ln of 2 over whatever is the half-life period, negative of ln of 2 over half-life period times t, right? Now A is equal to A naught e to the power. Again we will apply the formula like if it is natural log of 2, right? So I'll write it as natural log of 2 raised to power minus 1 and or negative 1. So it is natural log of 1 by 2. So natural log of 1 by 2 here and in one bracket and t divided by half-life time. Again, if you have e natural log 1 by 2, this is equal to 1 by 2. So A is equal to A naught 1 over 2 T divided by half-life time of that substance. So this is the direct formula for half-life. So we have three different formulas now. One is exponential decay, which is the original general formula of it. A is equal to A naught e raised to power this. Decays continuously. That is why we are using E. And actually E is not used in case of discrete decay formula. So you have to go to the previous section to check what is the difference between discrete and continuous. So, and we have derived K is natural log of 2 over half-life and half-life formula is direct this one. So if you get a question from the half-life, no doubt it's about decay, but applying this formula is much more easier. So instead of starting from here and doing everything right again, we can use this formula. Let's try one question. Suppose we start with 80 grams of a substance. Start with, that means it's A naught. Half-life is 10 hours. That means this is 10 hours. After 25 hours, that means this is the time where we have to calculate the amount of this substance. So according to the formula, A is equal to A naught 1 by 2. See, it has become much more easier, right? 1 by 2 T divided by half-life time. So amount we have to calculate 80 grams 1 by 2 time 25 and half-life period is 10. That means it's 2.5. Okay, so that is, you can use calculator, negative 1768, yes, is equal to 14.14 grams. See, in case of continuous, if it is discrete, right, and then we can make some guesses, but if it is continuous we should not, because everything is happening every fraction of a second. Now if I guess, let's see what happens. 80 grams initial, after 10 hours it will be 40 grams, after 10 hours it will be 20 grams, and after 10 hours it will be 10 gram. So 10 plus 10, here it is 20, and if you add all of them it is 30. That means you have to calculate here, right? So it will not be 15, because in this duration also it is decaying, so it's not 15, right? It's 14.14 grams. So in case of continuous decay we should not make like these kind of guesses. Apply the formula. I hope that is clear.